Band gap via GW Approximation tutorial. Create a simulation, by navigating to the Job Designer page. Then, open the Workflow tab, and select from the list the D1GW0BG workflow, whose naming convention is explained in the tutorial text linked under the video description. We now explore the subworkflow structure making up the overall workflow. First, try opening the SCF Many Bands subworkflow, used to perform a calculation over a large number of unoccupied bands. Then, open the Only Unit component, and inspect the WASP input files displayed at the bottom. The nBands tag sets the number of bands to a large value. Let us also inspect the contents of the main GW step of the computation, by opening the G0W0 step subworkflow. Again, let us review the WASP input files. The algo tag allows us to choose the G0W0 version of the GW approximation, the simplest one. After that, navigate to Compute tab, and set Compute configuration. Here, we use one node with 8 cores on the OR8 queue, because the GW method is quite computationally expensive. Then, set the name for the job. Here, we call it Silicon Band Gap GW Calculation. Next, save the job. It can then be selected and submitted to the compute queue, for execution. The status of the calculation will change from pre-submitted to submitted, and then to active. Please wait until the job has finished running. When the job is finished, open it, to inspect the final results. The band gap value can be found at the bottom of the results page. Here, we can see the indirect gap, of about 1.094 electron volts, in excellent agreement with the experimental value for silicon. This completes the present tutorial.